This is a resonance phenomenon. And if I think about it carefully, I can figure out what frequency resonates with this spring. If I send a pulse down on the spring on the top, and it hits a fixed boundary, in this case where it's clamped to the table, it will send a reflected pulse down on the bottom. Okay? It's going to be inverted. Now when it gets back to my hand is not moving very much. My hand is acting like a fixed point, a fixed end. And so that's going to flip it yet again. Now, if I time things just right, if I wait for the first pulse to get down and back before I send the second pulse, the two pulses will be right on top of each other. And then when they get back, I send a third pulse, and it's right on top of the first two. And then the amplitude will build and build and build. Now I can figure out what frequency is needed just with a little simple 205. Okay? I want to wait for that pulse to get down and back. If the length of the spring is capital L, I've got to go a distance of 2L with a speed V. Okay? That's how far I got to go. That's how fast I'm going. If you got to go 400 miles to Salt Lake City and you're going 50 miles an hour, it's going to take you 8 hours. That make sense? Distance divided by speed. Now, what we care about more than period, it turns out, is frequency. And frequency is just 1 over period, and so that's going to be V over 2L. Now, folks, you're going to see this combination of variables over and over and over again. We just won't give it a name. We'll call it Charlie. That's a frequency of 1 Charlie. Okay? 1 Charlie.